Alright guys, welcome to AtCoder. I'm almost late, but not quite. It's another beginner contest, 207. I actually had just enough time to type my template and stuff like that. We'll see how it goes. Recently AtCoder beginner contests may become a bit more complicated on average, I would say. Especially problems like E and F. I also don't have my command line compiler open. Okay, so okay, so problem A, that's going to be another sort of educational screencast in case you're wondering, because the feedback on the previous one was quite good, so I decided it's better this way, because we actually get time to think about what we are doing. I find it much better than just a screencast when I kind of breeze past easy problems, because there's always something to learn from a problem. Problem A, repression. There are 3 cards on the desk, each with a positive integer written on it. The integers A, B, C, you have to choose 2 cards and pick them up. Find the maximum possible sum of integers written on the picked cards. Okay. It's probably not optimal the way I'm doing it. Probably you can do it in a simpler way, but what cards are you gonna pick? Obviously the maximum ones, right? So first we need to read all cards, and it's always good to generalize things a bit. So for example, here we have 3 cards. And also make it const so that we know that's not gonna change accidentally. Then what you do is we said already that we want bigger cards. So probably we want to sort cards, right? And what you say is, well, I can actually, I want a sum of everything but the first element. I have to take a sum of range. Well, you say accumulate, then what do you say? I want to skip the first elements. That's exactly what I do by calling next of A begin. And then you want to go all the way till the end, and that's how I write this down, right? So hopefully I wrote it in the correct file. Okay. Accumulate also takes the sort arguments, which denotes the starting value in case you want to compute products, and obviously you can't use 0 as a starting value for product, right? Because you gotta use 1. In general, you have to use a natural or identity element, as they call it. As we just seen, it passes samples, so let's submit. And also notice that our solution, for example, works if there are not 3 cards, but any number of cards, which is kind of a nice side benefit. It got accepted. So generalizing solutions is good. If it's not complicating these things a lot. For example, here, obviously you can just manually select 2 bigger elements, but what if there are ties? Which one you're gonna choose then, and stuff like that? I don't want to think about it. I'm gonna say I'm gonna take everything but the smallest one. So I skip. I just use a built-in function into STL. It computes the sum of some range between 2 iterators, and it explicitly says that I want to skip minimum. Sounds very reasonable, I know. If you can't find such a generalization, it's perfectly fine to implement the straightforward logic, select 2 bigger cards by hand, but in general, you're not going to suffer from generalizations. So to speak. Problem B, Hydrate. There is a container with A cyan balls, Takahashi will do the following operation as many times as he likes, possibly 0. Operation is add B cyan balls and C red balls into the container. Takahashi's objective is to reduce the iteration number of cyan balls is at most D times the number of red balls in it. Determine whether it's achievable. If achievable, find the minimum. Okay. Now it's not always achievable because there are several things that can stop us. But the most general way to describe them is that we are adding cyan balls faster than we should. Like, ratio of B to C is greater than D or equal to D because there is some initial value. If the ratio is smaller than D, then we are always gonna win. We're always gonna achieve our goal objective. But it may take us a long time when the ratio B to C is very close to D, and that's why I'm converting everything into long integers, despite the input is not long. So, what I typically do is I'm just gonna write the equation down and solve it for x. Like, x is the number of operations that we did. So, like, initially there were A cyan balls, and we added B cyan balls every of x operations. And at the same time, we add C red balls every x, each of x operations that we have. And then we want to say that this is at most D times this. You get linear inequality on x. You subtract bx from both sides and you say like, well, okay. Now I can divide over that, and here we go. X is at least that thing. So, again, like, if this is negative, wait a second, if this is negative, then what? There's something subtle here. Okay. D times C is less than or equal to B. I think then there is no answer. Right? Because it means that we are adding cyan balls way too quickly. Right, I think then there is no answer. Otherwise, we would like that inequality to hold, but there is a minor difference. Like, when you have division, you always gotta think which way you run it. And in this case, because x gotta be integer, we want to find the lowest possible, the smallest possible integer that is at least something. Therefore, we are rounding up. How to round up? Well, first of all, I'm just gonna say that it's your denominator. Denominator. And then you say like this. It's just a common way of rounding up. I'm pretty sure that everyone understands how it works. But if you don't, pause the video here and think why this rounds. Like, this is integer division, and this works as a ceiling function. But I don't understand why it's a good idea to pause the video and think for a moment. I don't think that I missed something, but it's subtle. No, I think it's alright. Like the most important thing is that this can be long. We get around it saying that everything is long. Then we don't forget where the cases when we can't achieve our goal. Okay, I don't really know, like, probably it is a good idea to test it better, to come up with some samples. No, not samples, but like custom tests. But that's not what I really want to do now. And anyway, it got accepted, so moving forward, let's create file for E straight away. Don't know if we're gonna need it, but hopefully we will. So there is not much educational to these problems, just be careful, okay? Like, it's very easy to get a lot of penalties on these problems by not testing something like easy, something simple. And the simplest penalties is like you get 5 penalty minutes for every wrong submission. And every time I'm making a decision like whether I want to test something more thoroughly or just submit whatever I got, is like, is it worth it? Like, what time I'm gonna lose if I test now? I'm probably gonna lose at most 30 seconds of compile time and then running tests, right? Even if we account for the fact that there are like 6 problems, so spending extra 30 seconds on the first one means that on some platforms means that you lose 30 seconds on each problem, which still accounts to a total of 3 minutes. It's not worth 5 penalty minutes. And on AtCoder, the penalty time is the largest penalty time. Therefore, losing 30 seconds is losing 30 seconds. So if like being extra cautious costs you less than 5 minutes or whatever the penalty is for that specific content, then it's definitely not worth it. Taking penalties is not worth it. And as a beginner, you probably don't want to do that, like, because often it's not about who can solve more problems, but who can solve them faster and with fewer penalties. Okay, anyway, I'm getting a bit distracted. Obviously, not every one of our viewers is a beginner, so let's get back to solving more interesting problems. So, problems in many segments. We're given n intervals numbered 1 through n that are as follows. If ti... Okay, so we have all the segments, half open intervals, half closed intervals, some you can call them so, and then just open intervals. How many pairs of integers ij satisfy? And 1 is at... Okay, so from 1 to n, there are such that interval I and interval j intersect. Okay, we're gonna implement 2 solutions for this one. One is of n square, and the other one is what? Is n log n, alright? So now I'm gonna do it a bit more or less object-oriented style, because I think that it greatly suits such problems when you have non-trivial objects, or even trivial, but you just want to do some manipulations with them repeatedly and without mistakes. I think it's just the way to go. So I'm creating a custom struct for segments because I want to do stuff with segments a lot. In particular, I clearly want to intersect segments, right? Intersection, I assume you can call it. And what is the intersection of 2 segments? It's usually in other segments, its left bound is maximum of 2 lefts, and right bound is minimum, and right endpoint, I really should say, is minimum of 2 right endpoints. And I also want to know whether this segment is empty. Do I really want to do that? So I think, okay. So instead of segment, it's gonna be a half open interval. In general, this is just the way to go to work with half open intervals. I don't in particular care about lengths or anything like that. The only thing I'm gonna add is intersects. Which is just a nice wrapper. So what we do is we say like, hey, can you please take the intersection and check if it's empty? Check if it's non-empty. So just very nice. I think, well, obviously indentation can be improved, but that's irrelevant for our problem. What I'm gonna do next is I can create a vector of intervals. Not so. Or I actually, okay, yeah, that's. So I loop over all intervals and I say like, okay, I have a type, I have left, I have right. I'm gonna read them, and now let's see. We want to convert left to what? Oh. Just for convenience, subtract type so that there are 0, 1, 2, 3. Then what? Left has to be incremented by 1 if t stores 3, that's it. If this bit is set, then we want to increment L. If, what do we want to decrement, or no, we want to increment R if this is 0 or 2, that's it if it's not set. If this bit is not set, then we want to increment R. Because you gotta make them half open. So yeah, just a nice way of, I don't know, maybe it's not the best, but it is one way. Because like most of the time, if you have Cartesian product of several opportunities, you can use bit mask to do that. That's the same as like just checking if this one is the same as checking if t is equal to 0 or 2. No, if t is equal to 2 or 3, which before subtracting is equal to 3 or 4. These two guys, and then the same goes for this and this. Anyway, interval as we get constructed. I also think that I forgot to provide a default constructor, which is of course like this. Now the naive solution works because n is relatively small. So you're gonna count how many intersections I have. J is greater than I, so the pairs are ordered. Intervals at I intersects intervals in J was positive. Now, that's not optimal, but that's what was expected, judging from the constraints. Well, left of other must be... What? Oh, okay. Think that was our problem. At least one of them, clearly. I think now it works. Let's copy that. Let's paste. Okay. So I did something wrong. Okay, I mean... It's not ideal, but sometimes you gotta debug, and I'm actually doing it the wrong way. Because what you really want to do is make that a function of something. Okay. So one is this segment, and it gets to 1, 3 now. Second segment is 2, 3, and it's already half open interval. Second segment, or the third one, I should say, is 2, 4, 2, 4, 3, 2, 4. So it's, oh, wait, I'm stupid. I'm stupid, right? Because we... Oh my goodness me. I outsmarted myself completely. Because they can intersect not only on the points. Bro, that's a bro moment. Not only in integer points. Like, you can also consider floating points. So if the bus kinda covered 2, 3, but neither of them covers it completely, it's still an intersection. Yeah, I'm talking about something like, here's 2, here's 3, one segment is like this, and the other segment is like this. Once I change them to whatever I wanted, like this, they gets ignored. That's a failure. Bro. Okay, should have been more careful. But what does it mean then? Like, surely you don't want me to do all of this madness? Okay, I have a cheeky trick. Does it work though? Does it work? Does it work? I think it does. And you don't even need long integers for it. So if you introduce half integer points, and it works, right? Like you say, okay, I'm gonna consider still only integer points, but 2.5 is now an integer. 1.5 is an integer, so you scale everything twice, and then you are able to do what I did. Probably you want to do that after you add input. Obviously not before. Okay. Okay, now we are counting. 102. Okay, great. So, by the way, this, I don't know if we're gonna need this at all, but you know, always good to have print function for whatever structure you have. Now that was one way to do it. Let's Now that trick to work with integer points only is useful. I don't know how common it is, most likely not common at all. Anyway, so let's submit this for C. And should work, right? Okay, that doesn't take much time because n is only a couple thousands, I believe. Well, 2,000, whatever. Now there is a better way of doing the same thing, which is as follows. Should I? No, I'm just gonna delete this. So it involves the technique that I called event processing, which I believe is not a common name, but who cares? So each event has position, has an index or any unique identifier of that event, and then it also has a Boolean value indicating if it's opening or closing. And I believe that we want to process opening events after we processed closed events because our intervals are half opened. Now I don't think that I actually need to write it, but this constructor, I'm not really sure. This should, yeah, that's actually awesome. Looks nice here. This is extra, this and we need that operator defining which event is smaller because, and that's important because we want to sort our events in order to process them, like in order, you know. So anyways, we sort by position first, then we sort if it's open or not, and then just to make our order complete, we use index. So that's any two events we can call, say for sure that one of them is smaller than the other one. Because having complete predicates is good in general. Now every interval is going to be converted to two events for the beginning of the interval and for the end of the interval. So what we're gonna do is just ask straight away for enough space, and then we're gonna say what you say. Like events at 2i gets event of something intervals at I. Surely you want to do something with that guy. Probably you want left position, and you say like, okay, what is its index? It's I. And is it opening? Yes, it is opening. And here you want to say the same thing, except for its closing, and also it's 2i plus 1. And that's just a fancy way of writing 2 times I plus 1. I prefer that, so I don't know why. Long time ago, I needed actually that for indexing somewhere to pass. It was like n-log cube or something like that, which was very tight, and I just needed every bit of performance. Most of the time it's irrelevant. So if you're used to writing 2i plus 1, or use 2i plus 1. If you're not using to think about indices in general, you can always push back into the vector of events. or even in place back, which I believe could be faster here. Not sure. I think fastest way is to reserve and then in place back because of the construction time, but that's something you gotta test yourself. So if we sort our events, then what we can do is sing on a count intersections. Now we also want to count opened intervals. So how do we count open intervals? And in this particular case, we actually don't care about index, but in general, you may want it, so I just added it there. But here, I think we don't need it. So if events open, you obviously want to increase that, otherwise you want to decrease that. And I think that you increase it by count of open intervals, but in the different order because no interval intersects with itself. So that's another way to solve it, and often you have to come up with n log n approach for interval problems. And we are dead. That is just so wrong. I don't even understand how it could have happened, because how do you even get 7? 7 is way too much for 6 events. No. What if no, I need default constructor, I think. Sorry. Okay. How do we? I still don't understand. Okay. More debugging than I would like to, but it happens. Oh, of course, because we only count if it's an open event. When we close a segment, we don't care. Like, we count when the event opens. We count how many active events are there, so we count all of them. Good plan. Sounds like a good plan. Okay, got 2 here. Got 102 here. We should submit this version as well, just to check if it's correct. You may say that it's already complicated, but sometimes you have to do that in off and log n. So that's why I did it. I think that on this particular, if n is, no, it's a bit faster, but that's not really something you care about. If you see that naive solution passes, absolutely do that. Yeah, just do that. You may see that we spent like 8 minutes implementing a more smarter version. Not something you want to do. In a rated contest. If you train, well, implement whatever you want. That's your time. If it's about your rating, then you probably don't want to do that. Although some people clearly don't care. Like, I don't know, Rainbow. Somebody else probably. In problem D, Congruence Points, we're given 2 sets of pairs of endpoints in a 2-dimensional plane, each endpoints. Okay. Determine whether it's possible to do the following operation on S, any number, possibly 0, any number of times in any order so that S matches T. We choose a real number P and rotate every point in S p degrees clockwise about the origin, or we choose real numbers Q and R and move every point in. Yo, dude, what? Okay, I'm gonna remember my math class. Operations of rotation and translation, they give birth to a bigger class of operation, but how they are called. Okay, so rotations and translations. I'm not going to try to. Okay, do I care about reflections? I think I don't. Okay. Dude, I don't know how to Google that in English. I just know that in Russian we call it move. What is it? Motion? Okay, yeah, makes sense actually. Group of motions. Given a geometry, yeah, but can you please tell me something more specific about that group of motions? Because I remember that they form a group of some. Yeah, sure. Oh, okay. Screw displacements. Cool. Dude, can we please talk about plane and not just some abstract stuff? I remember Charles' theorem about something. So essentially what this theorem is saying that you can only use two such operations, I think. Oh, okay, I know, I got it. It's like I was trying to come up with linear algebra approach for this problem, but this does not require it. Because if you think about, like, you have endpoints each, you gotta match them, right? Like the thing is that you can rotate not only about origin because you are given an ability to translate. So, like, imagine that you have some group of points that you, imagine that you got a square. That's just easier to see. That you want to rotate about that point, but your origin is all the way here. So what you do is you first translate it here. I should use arrows. So you translate it here, right? It got here. Now you can rotate it. I think I can't rotate it in Zoom. So imagine that you rotated it like this. No. Dude, that's uncomfortable. Okay, so you rotated it 90 degrees, I don't know, whatever. And then you want to say, like, wait, but I actually wanted to rotate about that point. So you say, okay, just let me translate it back. So in fact, you can rotate around any point, and therefore all you care about, like, you have to move one point so that it corresponds to another point. And once you've done it, you want to find whether it's possible to obtain one from the other, via some rotation in the following sense. Oh, can we do that in like... Okay. So how does rotation works? You clearly can't think about all possible angles. So what you're gonna think instead is like, let me match 2 points. 2 points. I know that these 2 points are getting into these 2 points. And then all I care about is whether they remain like moving 2 points into 2 points. I think that there is only one way to do it with translations and rotations, if you limit it to those. Like, there are other geometric transformations. For example, obviously, if you can flip things around, then you're getting, you need 3 points, right? But I don't think that you need it here. Okay, it's S and T. I think it's CX, CY, just like that, right? And TI, TX, TIY, TIX, TIY, you got it, right? All right. Now, what is the simplest way of checking whether the result is going to be correct or not? My claim is that every point is uniquely determined by its distance. Okay, so we have 2 points, right? I state that, like, for example, they were here in S. I'm saying, okay, they went into some points of T. Every other point is now uniquely determined where it goes. X is wrong. How? You take distance to S1 and you take distance to S2. And there you say, like, if I now think what points are at a given distance away from D17, the same distance that S3 is away from S2. That's this circle. Then you draw another circle, and you can see that there is an intersection point. You may say, actually, there are 2 intersection points, and you will be absolutely right. And because of that, we are also going to introduce whether it's this directed angle is positive or negative. Because here it will be this way. Here it will be this way, like it should be, right? But if you say, like, I fix in this order, then this is counterclockwise and this is clockwise. This is counterclockwise. Therefore, your point will be here, and it matches logical reasoning. So once we have all that in mind, I should move it somewhere where it doesn't. Okay. Now, do I want that, or do I want something more reasonable? So I'm gonna return actual square distances, because why not? Because why not? Because you really don't want to work with floats, not at all. And my idea here is, if I want distance between 2 points, then I should just implement the way to subtract points from each other, just like you do with normal complex numbers. In order to take the distance, you subtract and you take the absolute value. That's exactly what we are going to do. And actually, yeah, okay, just call it. I don't know, it just looks better this way, but I don't, yeah, that's got to be true, right. So x minus other x and then y minus other y, so that's simple as yes. Now I don't remember, and it's bad thing, but I don't remember how to compute directed angles. So no. Well, obviously you can also copy paste this, but that's just not something I like. Angle? Do I want an angle or do I want what? Oh, they actually using this, which is the same, but it's not quite. Dude, where is okay, oriented area, okay. Clock, yes, that is something we need. That is something we need. Maybe I should have just copy pasted 0 points, right? That makes sense. If I'm gonna use something, I should just use everything. Except for indentation, that's something that you don't discuss. Something you do without questioning. I should paste links because some people will certainly suspect me of cheating. Especially if it was like lit code. Guaranteed. Guaranteed. You're not getting away if you don't post a link to your sources. It was just getting ridiculous, so. Oh, actually they have their styles, so okay. Now we have this and that, and unfortunately, okay, we're gonna use that. That's not a big deal, right? Now, what is our idea here? Is it true that n is at least 2? And is it must 1? Okay, bruh. Because what I want to do now goes as follows. I want to loop over all possible points in T into which points of S go to. Though there is not that many of them. Here now that as Dira got into Ti, this one got into Tj, Ti, and Tj are different. Now I gotta check if for every point there is the correct entry in the corresponding map. So the way I'm actually, how am I gonna do that? Okay. I think we can do that. Like everything here is reasonably small, if you think about it, because all coordinates are up to 10. Actually, because all no, this is the way to go. I can use just sets, right? not as, but I don't know, used. So my idea is as follows. I'm gonna loop over all the remaining points, and then I say like, want to increase y where? First is distance. So distance from where to where? From sk to s0. We can subtract and we can call where is the y? Okay, no, absolute value is of course defined outside, but just okay. What is f-type? What is f-type? I'm gonna call that everything is integer. Just like this. No, so that was wrong. Okay. Points 3D, we don't care about those. Angle, projection, not so. What I care about is norm. Okay. I'm gonna call norm of that is the first argument. Oh, this is a set. Okay, so I'm going to insert that or in place, and I need this, and then I also need, I think, clockwise of S0, SK, S1. Sounds reasonable, right? Right. Or at least I think so. F is going to denote if we found an answer, or we're gonna exit with 0. Okay. Now our task is to loop over all points in T if it is different from the 2 points that we already got. Oh, there is one more subtle issue. I just have to check more thing, which is if norm of S1 minus S0 is the same as norm of TJ minus TI. Because if it's not, then this construction doesn't really work, I think. It may produce you wrong answers. So here I want to effectively remove it from that set. So if not you, can you erase the entries that's not here? I hope you can. What I want to erase is more or less the same thing, but for as you substitute T and for for rest to substitute that. Does it like so? Just erase. Well, I'm a bit worried about it. I'm gonna use something that I'm fairly sure works. The worst thing that I may need to do here is change initializer list to tuple, to make tuple, but I think that it's fine this way as well. Looks very reasonable given that we had such things, right? And then the point of all of this is that you can check if every pair of elements was satisfied. So I'm just gonna say like pool any is wrong. I'm gonna say all are satisfied, so initially all are satisfied, and if this stays the same, then I print yes and exit. Otherwise, at the very end, after I tried everything and failed, I print no and exit. And how do we deal with that? We can loop over our map. Use such a bad name and change it to map. Sorry. No. If map, if value equals oops. I believe we don't need our drawings, they're just distracting at the moment. Because they're distracting me. That's just not good. You're spending a lot of time here, and also cross identifier not found. Are you kidding me? Like, why you can't just give everything in one listing? Who was that genius that came up with? So for some reason it returns F-type. Honestly, I have no idea why. Line 99 something went wrong. Where? Okay, my bad. I admit it. Study map to few template arguments. That's correct. Got to take the value in. Okay, it looks like it got it. Okay, the answer is yes here. The answer is no here. The answer is yes here, and the answer is yes here as well. Okay, very difficult problem D. I imagine that a lot of people will be angry about that, because nobody likes geometry, honestly. Well, I actually know people who like geometry, but that's their fault. Okay, no, that's 64 test cases, more than you will ever see anywhere else, but it got accepted. The only downside is that we spent 25 minutes implementing it, and now we only have 40 minutes for E and F, which is actually our fault, but yeah. Now, like, for a more optimal solution, this works in of n cube time, because you trying to restore by 2 specific points at n square already, and for all pairs you need of n check if it's a correct restriction. And what I think you can do instead is no, I actually don't know how you may be able to do that. Okay, I think that there's of n squared solution which works approximately as follows. So you're trying to get like one point correctly, and you're trying to get the angle. And the angle can't take that many values because for every point you know that it gotta go either here, here, or here. Now what is a better version of that solution is for every point you can, like, imagine you have a central point. Now for every other point you compute directed angle that it forms with O x-axis and also the distance. And now after some rotation these guys should match, right? What is the rotation? Well, most of the time you know that there is only one longest distance and it's got to match the longest distance in t. So you pretty much get your angle for free, and then you just check if this angle works or not. Now sometimes you will have more than one longest distance, but I imagine that's not going to be often. In general, you will have at most of n matches over all n centers, because it's hard to have, I don't know, 4 points which are all equidistant in a plane. Just plane doesn't work like that. And if it doesn't, then it's kind of hard. Like you need. Oh no, never mind. I think I was wrong, or was I? No, I think I was not. Wait. Like, what if you have like real triangle, but not triangle, but like n-gon? Did it have quadratic number? No. It surely it has linear number of longest distances. Yeah, I think that's an extra interesting math problem. Like, proves that in any set of points in a plane, there is a linear number of pair of points that forms the diameter of that set. It should be really easy, but I don't see a nice way to prove it, not yet. So anyway, problem E modulo I. Given a sequence A of n numbers, find the number of ways to separate A into some number of non-empty continuous sequences B1 through Bk, so that the following condition is satisfied. For every I from 1 to k, the sum of elements in Bi is divisible by I. And the count can be enormous printed modulo. Okay, now we can. I know a good library for working with modular integers. I imagine that I want to get used to using it at some point. So why not now? It's an educational screencast after all. I'm a bit concerned about that. This size, what that's like. Okay. I think that's the file that we want, but I'm a bit not sure how it works. Okay, it says here, let's. What if I just want to say that it's mint now? I'm telling you it's mint, okay? And I just gotta work with mint and I'm gonna be good, right? I think so. Whoa, okay. That's some simple DP, right? And we can actually... No. Wait a second. Divisible by I. It's so okay. Now I clearly want to have some DP here. There are not that many segments. The problem that I'll face, it sounds like my DP is cubic, the one that you get straight away. Because what I want to do sounds approximately as follows. Like for every position, I want to know how many ways there are such that it ends with case block. Sounds reasonable until it doesn't, because... Or does it actually? Oh, never mind, it works with some minor changes. Okay, so n indices. Position, block number. Block number sounds like blockchain, whatever. That's why I did not really want to use that name, but what is it? How many blocks? N. It must. Your blocks. Your length is 1. Probably you want to then do that and also that. Is it correct or is it not? I think it's not. K is how many? Now should come something like that. What counts as also nodes? What will be our answer? That's a good question. Can't really use A. Let's say S because it sums things. What should we do? We should access this, right? Or rather this. Now at the moment it should list compile. I just want to quickly check that it compiles. I cannot open file encoder internal mass. Not cool. Internal type traits we will also have to include. That's not that nice as I thought it will be. I imagine that we also want internal type traits or something like that. Where's type traits? Okay. Well, at least it does not include anything itself. So it's like there are not that many recursive dependencies. I hope our source code is not getting like too big. Huh? Or did I copy the correct link? Yes, but something is still wrong. Mint is undeclared identifier? What do you mean? Like surely I have using here. Oh, it's inside. I didn't want to change that actually because it may be used somewhere else. What I mean, there is, I just, okay. How do you, there is static mode in traits, so, wait. Oh, you just get to value? Okay. You want to call value of that. Not nice. So, but I imagine that you have to do it if you. I actually don't understand why you can't just declare a stream operator, fine. But whatever. Now you have to be careful. So I'm gonna try to add one block. Oh, that's terrible. I gotta stop recording and take care of my running mouse for a moment. I'm back. We still have 30 minutes or so to go. Okay. What I think is that we need running sum, perfect sum or whatever. Because I want to do the following. So as gets incremented by AI, that should be just long. If s no. This should be an this should be an arrow map. Yes. Bro. So complicated, it's okay. So map counts how many within prefixes that have given remainder modulo AI. DP adds okay, I assume. Probably I+1 though. It's also okay. Okay, yeah, makes sense. Then probably like this then. I'm confused. Because surely I want to increment that by AI. And kinda, what happens about that? Shouldn't it get like 0k? I was thinking get 0k and this one gets this. Okay, that makes sense. Now DP it's I+1 k+1 should get map of S before this happens. Is it so? Go on account how many ways you have to get prefix sum, given some remainder. That's absolutely right. So you want to say that it gets modded by this, actually. You want to be divisible by the number of the next block that you are adding right now. There's no way that's gonna work just like this, right? Okay, so far so not bad, I guess. Now it's gonna break. No, it doesn't. Now it's surely gonna break. No, okay. Maybe I just can write correct codes without mistakes by using completely new library? I don't know. It doesn't sound likely. Like, you gotta admit that it does not sound likely. Surely something's wrong. Code size. Okay. Well, that's kinda on the edge, and my guess it doesn't have to do with my part. Although I probably can speed things up by saying that, hey, what is that? What's that? You only need how many k+1 remainders possible? What is k+1? Sorry, you completely ignore everything else. Oh, everything got wrong. Went wrong. Did it right? Like maximum remainder is k, so therefore we take k+1 and it should just work. I'm going to explain the solution, but hopefully after we solve f. Also, I did not run the test, which I probably should have. I don't know. Okay, yeah, that was on my side completely. Okay, I admit. Another pause because that's just unbearable. Okay, I'm going to explain this later because you kind of got that it's DP and you work in modulo and stuff, and for some reason it works, and this is the speed up on naive off and cube version. We are going to discuss it later, but I hope that I can also, I don't know, I have 20 minutes, but if you think like this took us 25 minutes, this took us 20 minutes, so maybe we'll get an F in those 20 minutes. Bruh. I don't want to do that again. I'm just gonna be stupid this time around. So we have a tree with n vertices. The ice edge connects to vertices. Okay. Hopefully it's some easy DP on the graph that we can quickly solve, because if it's not, then I'm gonna be kind of disappointed to live without solving f. That's kind of what you want to do if you're making an educational video. Okay, we read our tree. We'll choose some vertices, possibly none, and place a Takahashi in each of them to guard the tree. A Takahashi placed at vertex x will guard x itself and vertices directly connected to x by an edge. There are 2 to the power of n ways to choose vertices for placing Takahashi. In how many of them there will be exactly k vertices guarded by one or more What the dude? I'm sure that you want to ask that question, because it sounds a lot like DP on a tree. Okay, so what we typically do is we're gonna say, okay, take our root, right? Because it can be anything, but it's nice to have a root. Imagine that our DFS is actually going to return things once in a while instead of doing nothing. I mean, instead of modifying some useful data. It can return that, so I don't particularly care. Okay. It's not likely that it's going to return an integer, right? It's going to return a map. Okay. It's just... That's just not something I want to do. I think I never actually need that because I'm gonna say that, hey, hello. I'm pretty sure that the solution goes as follows. You get to count how many ways there are in every subtree to cover exactly k vertices, so you can do it more or less recursively. And for efficient implementation, you I probably don't care. Oh, actually, we probably don't care. But anyways, I already started typing and I just want to get it done. So don't do nothing here. Well, you can delete second, but it's relevant. Therefore, you're going to return that. At least you're saying, right? Actually, where is k? Oh, for each k. Okay, that's not a big deal. Obviously. Oh, that should be returned, right? So I don't think we're making it on time, unfortunately. Obviously we can try, but it's hard. It's really hard to write that match code without mistakes. I think it's fine if you do just this. So I clearly also want to do it here, because otherwise you're just not getting anywhere. Just so bad. Okay, the only problem is though that we probably also want to check whether we take the root or we don't, because it makes a difference. Okay, anyways. Both of them? Oh, that's okay. Surely you want to mark visited vertices, right? to be clear, I don't have a solution in mind. I'm just pretty sure that it is going to consist of these building blocks. Because it basically has to. There is no other way of doing it. Probably here you want, okay. And this is 1. This is 2. Adding 2 numbers which are not greater than 1 billion. We're gonna floss, that's fine. Here I have no idea how the solution has to go, and we only have 13 minutes to figure it. Okay. So this function shows a map from number of vertices that we cover to number of ways to do that. And that's why we would like to merge them like so, by adding. By preserving the key by adding. They only count in subtree. Therefore, it means that if you don't take that vertex, oh my. How about that? Okay. Probably margin is relevant because we can do it naively, right? Okay, never mind. So I just lost some time there. Stupid. But that happens. Like this takes the root vertex of that subtree. Okay. Because it takes that vertex, it's also going to take us together, and therefore p at k plus 1 should get added value, should absolutely get modded. If you go here, like we are taking current vertex, what does it mean? Despite not taking that vertex, oh shit. They're just getting worse and worse and worse. I'm just gonna say that. I'll let you guess the meaning. It's basically relevant what you're gonna put here. Yeah, no, that was kind of trivial, obvious, based on what we have here, but I really wanted to avoid it, unfortunately. Okay. Now, you see, the sync is that here we want to return P, just clear. Why do we have any sort of trouble here? Oh, I know why. Okay. Not first, but second. More or less similar sync here. Not sure if it helps at all, but it's too late to rewrite. So key second tells us if we got the root of that subtree together with us. Probably if we got it, then our vertex is not going to add anything dramatic to it, right? Oh wait, oh shit. Oh shit. Oh man. Okay, I just completely. I should have thought about it, but we have a big problem here. Like it's called that it's a tree, but then you have to think of the values that your children report to you, how are you gonna combine them? That is so bad, that's so bad, that is so bad that I don't know an answer for it. I can't, okay, no, that sounds not bad, not that bad, right? It sounds like n cube. I have on, okay, no, that's completely. That is wasted, that is wasted. But I have no idea how to do it faster than n cube. No, never it has gotta be faster, right? Or not, or is it? Or is it? On average it's n squared, but there's no way I'm gonna write it right now. Damn. I probably can figure out the details if you give me like 30 more minutes, I don't know, half an hour, something like that. And no, the idea is correct that you want to count how many ways there are to cover exactly k vertices in a subtree of some vertex, and also considering two options, like whether you cover the vertex or you don't, and whether it got covered via some other vertices or it hasn't. Based on these three values, you can say like what's gonna happen next. How do you say it? Like you create an empty map in the current vertex and you try to merge it together with the previous map. Oh no, it's still n cube, right? It's still n cube. Damn it. But in general, how do you want to merge them together? Not in the sense that I discovered, explained. Not in the sense I caught it, because I didn't really explain what's going on. But you want to think like this subtree has that many choice ways of adding something to our existing cover. It's gonna depend on whether you take the current vertex and whether or not the vertex in the subtree got covered. So you have like your array of then 2000 or n. It counts how many ways there are to cover how many vertices. For every children, you get the array, the same array for its children, and you just increment every value by that value and plus equal value. I increment every key by every key of the children and increment by the value of the children. Not increment by multiply, I think. Yeah, multiply that. Where is it? No, increment, because that's just... No, multiply, right? Multiply, you gotta know. Okay, that's confusing, but I think you got to multiply. Because otherwise, like if we add, then we're not getting more than 2 times depth. And if depth is 1, then we're clearly doing something wrong, therefore we have to multiply. Yeah, we multiply. It's still in cube, I think, because you have n edges in the tree. For every edge, you do n squared work. Because you need to have current value and then value that you're multiplying with. You need 2 for loops. I think that's... No, I don't have a better estimate. It's just bad. It's just that bad. Okay, anyway, something like this. I think I should fix it later, because I promised you to talk about E. I think I can't explain D well. I only explain E, what's going on in E. I remember E. We wanted to count partitions of A into blocks such that sum of every block is divisible by its index. And what I said is that we're going to have dynamic programming on whatever is the length of our array, and actually how many blocks we have. And at most we actually have n blocks when every... I shouldn't write here. So it's our array A, we can have at most n blocks when each element is in its own block. How do we count it? Like we know that there is one way to have 0 blocks with using 0 elements. Now 0 blocks, just blocks, elements. There is no way to use elements but don't get any blocks. So that's all zeros. And then everything else is going to be filled as follows. But we have I elements and k blocks. I really should draw it like here. I elements and then k blocks. Where does it come from? Like, obviously before that you had 1 less blocks. So you were somewhere at k minus 1, and then you were at some index j that's smaller than I. Right? Okay. Now unfortunately you can't just loop over all possible values of j. And what we do here, because you are looping over I already, so you can't loop over j. Now what I suggest is that all these j values, at most they can be divided into congruence classes based on what is the sum of this part modulo k. because we want this thing to be divisible. How to get this thing? Well, simple. You take this and you subtract this, right? As usual. So we want to check actually, want to group J's that gives the same value of prefix sum modulo k. How to do it? Well, use a hash table or use a vector of length k plus 1 if you're smarter than me. Than my original attempt. And this way, when you get to I, you will know where to look for the cumulative value of all j's that gives the correct remainder modulo k. So this way, you're taking your complexity down from looping over I n over j to looping over I n efficient lookup for j, which is 1 n less. So therefore, you get from of n cubed to of n squared. That's how E works. I should also show you the standings, I believe, of how terrible we performed in that contest. That was just bad. I mean, like 25 minutes on D. D not solve F. I don't know what to say. Yeah, not in top 100. I recently discovered that you can click on the flag and you will get all people from your country. They're not doing bad. A lot of people, I assume, skipped D because that is just bad. Actually, I'm surprised. If you can solve it that quickly, why you can't solve D then? Hello? Excuse me? Dude, like, are you kidding me? Because what? What went wrong? Like, surely you can brute force. Surely you understand that 2 points more or less gives it any motion of the plane. So, what went wrong? Is it so massive that's like only I could solve it in Ukraine? That can't be true, right? Like, obviously none of high-rated people write AtCoder beginner contest, but that's a different question. Let's get back to let's get rid of Ukrainian filter. Yeah, you as you can clearly see. Oh. I'm very surprised. No, if I'm honest, I'm not surprised. Because I knew it's gonna be that way. Nobody likes geometry. You can see the solve count is 1 in 5. The solve count for E is 1 in 2, and the solve count for F is almost 100%. It kind of shows that, like, if you had enough time and was smart enough to implement it, then you're getting there. No. Obviously, I did something wrong, and it took a lot of high-rated people and smart people a long time to get there. So, yeah, that's may have been the correct strategy for this one. I imagine I'm gonna be the no, okay. Well, some people had to skip E to get F. That's respected strategy. And some people just did AE nicely, and then just didn't do F. Okay. Oh, we overtook those people only because of penalties. Okay. It's such a shame that we could not solve F. But it looks like not that many people saw it, but still, like 100 people, mostly Japanese. I just have to work more, apparently. Okay. That's it for today. Thanks for watching. I hope you enjoyed the kind of educational content, because there has been warm feedback on the previous such video. So hopefully I will have enough time to make one about ABC every week. And hopefully at some point I will be actually able to solve all the problems and explain all the problems, because I really want to, but to get good, I guess you just have to practice more than I'm doing, and I need to do something about it. So anyways, that's it for today. Bye bye. Hope you enjoyed.